Hi, welcome to the first session of the December 2022 edition of the Open Security Summit. And we're going to start with a bang with probably one of my favorite topics and one of my favorite presenters and security professionals, which is on an amazing upwards trajectory. Couldn't be prouder. So we're going to be looking at threat modeling as code, which is actually something that we had several sessions already in the summit. So check out the past videos. And it's definitely one of the ways that you can scale threat modeling. So Petra, over to you. Oh, sorry, and Chen, sorry. Petra and Chen are presenting, sorry. Both of them are going to be walking us through their latest. And we're going to, again, try to make this as interactive, asking questions and trying to learn as much as we can. Petra and Chen, over to you.
Cool. So hello, everyone. So yeah, this session is interactive, and I would love if everyone participates. Please don't be shy and just, I don't know if you can turn your microphone on. Is it set that way that anyone can talk? Dennis, I hope that's the case.
Yeah, I've already made a number of people co-host, and if anybody can ask the question, then I could always make them.
Cool. Cool. So either ask to be co-host or put the question in the chat. And yeah, so this is kind of how I'd like it to be. Obviously, this framework that I've created is open source, so I'm going to put the link in the chat in a minute later when I present it. And anyone who wants to contribute, has any ideas, please feel free to create either issues or in GitHub, or just kind of create a pull request. If you want to like even upload samples that you've done, like anonymized, you can do it in the repo, create a new folder in the repo and do it. So yeah, I'd love if everyone participates. So just how this session is going to look like. We're going to talk a bit, just a recap of the framework that I created. I advanced it a little bit to, from pioneers to a settlers version, how to use it. And then Chen is going to talk a little bit, Han is going to talk a little bit about how we used it. Basically, we're going to answer a question that's been posed last time I presented, and that question is, now that you've got this security.json file, what do you do with it, basically? All right, so just a quick intro on myself. I'm Petra. I'm Director of Cybersecurity at Job and Talent. Recently got promoted from senior security engineer. So I'm quite technical. I have my own kind of things that I'm enthusiastic about, and threat modeling is definitely one of them. And over to you, Han.
Hello, everybody. Thank you for joining. I'm Chen. I'm co-founder and chief architect of Enzo Security. Enzo is building an ASPM platform that is used by Petra's team as part of their security program. I live in Tel Aviv. I really like to build things. Some of them are, sometimes it's software, sometimes it's other things. And yeah, I'm happy to be here today.
Cool, thank you. All right, so a recap of the previous version of threat modeling as code and kind of what was the idea behind it. By the way, all of these images are created with AI, so with DALL-E. All right, so essentially the idea behind creating a threat model as code is the fact that the threat model is, alive as much as the software is alive. So it lives and breathes. It lives in the repo where this, where the code lives. And that way we can see it as a, journey, not a destination. Because a lot of times we think of threat models as in like, oh, we create this report and that's it, that's done, we're finished, but we're not. First of all, we don't have to be perfectionists to make a perfect threat model. It's never going to be perfect. We're always going to think of other things that we might have missed before, and we can keep updating it. Secondly, the code changes. So we always have to revisit that threat model. So the beauty of it living in the code is that you get the version control, you get the scalability. As I said, lives close to the code. That means lives close to the devs. And something that we all love to see is to actually see developers doing threat modeling. And this kind of brings it even closer to them because they create PRs every day. So creating a PR that will create a threat model output is just one of the things that they can do. And then lastly, why a JSON format? and that's the new version of it. I used to create it in MD. Now I change it to JSON, and the reason why is because it's machine digestible. So you can later, you can do a lot of things with it. You can put it in dashboards. You can use it to track your security, maturity, the progress of the overall threat modeling in your company. You can track the progress of the controls that you're trying to introduce with threat modeling. I was even thinking like, things like, potentially use machine learning later on top of it once you have your own data set. So yeah, Timo's got a question.
Yes, why not a YAML?
Good question. To be honest with you, I'm just more familiar with JSONs. I've worked with JSONs a lot, purely because, when I started my Python coding journey, I worked a lot with JSONs. So for me, it was just a natural progression, and using JSONs in Jupyter notebooks is much easier, and they can be transformed much easier into pandas data frames as well. So it was kind of more a practicality reason. I'm sure that you can also do it with YAML. So JSON is just something that I've chose because I'm more familiar with it. There's more things that I could do with it. Like, for example, as I said, turn it into data frames, use it in Jupyter notebooks, create graphs out of it. So I found really good ways to create graphs out of it, which I'll show you in a bit, which is I haven't found with YAML. So yeah, that's kind of the reason.
Okay. Do you expect people to write it as JSON, or is that generated?
I'll show you. So it gets generated, but you do have to write your own threads. So the purpose of this JSON is not to have a pre-created threat, because I found that that can be quite hard, to have completely automated threat modeling process. I think there still needs to be a threat modeling session. There still needs to be, people around the diagram talking about it, at least as a start of the journey. Later, that journey can be kind of completed with potentially some automation, but this is more of an output of a threat modeling session, and then later you use to track those controls, track those threats, and see the evolution.
We actually had a good question from Chimnoy. Are you able to unmute and ask the question, or do you want me to ask for you? All right, I'll ask it on this. Okay, so the question, Petra, is, this is great. How do we get started with a user story driven threat modeling for an existing app and showing the value by trying it to the overall threat model?
So just to get the question right, is the question, how can we melt this with a user story based threat modeling, or can you just clarify the question?
Yeah, I think that's it. How to get started with a user story driven threat modeling, right?
Am I audible now?
Yeah, we can.
Yeah.
Oh, thanks for asking the question. The mute button got stuck. The question is more from a perspective of an existing application. So if we have an existing application, and if there's a user story that is being developed, maybe to add a new feature, how do we have a threat model, and it's for a critical application, let's say. How do we threat model that particular user story, and whatever the outcome of that model is, the perceived threats are, how do we tie it back to the overall threat model of that application, right? So there would have been a threat model done for an application, right? Yeah. So and you're saying that this is living in the repo, the code repo, which is great. So is there a way where the threat which is impacting that user story, it could also have a bearing on the overall application's threat modeling status, right?
So it's a really good question, because there's a lot of approaches to threat modeling, right? Like you can threat model like a user story, like you're saying, or you can threat model an individual service if you got microservices. You can threat model a whole application. So this kind of threat modeling that I'm describing is best implemented where you're introducing threat modeling of every service, and then that ties into the other services. Obviously, you can threat model multiple services at once.
Got it.
That
Okay.
can create a user story. So for example, if you're kind of threat modeling a user story, you definitely need to know which services, if you have microservices, which services are kind of inside this user story. And that way, the threat model that you create, you just upload to different repos. Because we had similar thing where we kind of threat model the whole data flow that our data team does for analytics. And it involved like 4 or 5 repos because it was 4 or 5 services. And what we did is we just created these security .jsons which are basically threat models for every single repo that was involved in it. And we just specified which one is the one that's kind of applicable to, and if there was any difference, we would just note that there. Does that make sense?
It does. It does. It does make sense when you talk about the services part. Yeah. Thanks.
Yeah.
Is there a way we can reach out to you? Because I have reached out to your team for application security posture management, right? So we're having a discussion there, but I would love to see something here as well in threat modeling part.
Sure, you can find me on LinkedIn. I can put later, once Han is saying his part of the story, I can put all my links in the chat.
Sure, thank you.
Cool. Okay, so the difference from the old version that I presented quite a while ago on the Open Security Summit to now, so basically I started with like the Pioneers version, which was just kind of, experimental. I just did something. I wasn't really sure where I'm going with that. And now I'm going into Settlers, where I kind of understand where we're going with this. We have a good flow. But the story is not finished there yet. So the difference is it used to be in Markdown format, and now we are creating it in JSON format, as I said, and for the reasons that I stated earlier. And yeah, as I said, what's new? Added JSON version, small enhancements, improved README. We're going to have also, hopefully soon enough, another version of the README file that helps step by step with setting up the environment, and hopefully more examples. And how to use it. Then now I'm going to do the demo. Actually, I'm going to show you how to create it first. I'm going to stop sharing for a second. And I'm going to show you the Jupyter notebooks. All right. Okay. So this was the Pioneers one, as I said earlier. I've also shown some diagrams, like how you can create diagrams with code. That's also quite nifty. But what I want to show now is this one. Now, I just want to make sure, is everyone seeing my TM JSON Settlers notebook?
Yep.
Yeah. All right, cool. So I'm going to try go through this quite quickly because of time. And then, everything is very well documented, so you can go back to the repo and read it. But yeah, essentially what you do once you set up the environment, and the way you set up the environment is because you have the environment.yaml file, and you use that with Conda to create a Conda environment. And then that will have all your dependencies that you need for this. It's not a lot of them, but yeah, it's something that you need. And it's mainly to generate the graph. That's the main thing. The README file explains very well, but I won't, for the purpose of this, I won't go through it.
Actually, can you share the GitHub repo that has this?
Yeah, do you mind if I just share it
Yeah, fine. Yeah.
in a few minutes? Yeah. So I'll share it. Yeah, I'll share it in a few minutes. But basically the way you do it is, let's hope the demo gods are in my favor. is you first, you import your libraries. As I said, mainly you have the iPlant UML and Plant UML just to create the graph, because I added in the graph creation at the end. And then what you do is you input the data. And this data you get either a little bit before the threat model, or you get it during the threat model, like the threat modeling session. Now, what we do is we get the devs to gather this information. So they start the threat modeling process. We have our security champions who start the threat modeling process. They invite us obviously to the process, but they're the ones who trigger it. They put in the review of the, date of the review, which is the date of that we're going to all have the meeting, date of the next review. And the next review depends on, for example, in our case, how critical the service is, which we determine by a lot of factors. But you can do it, however you want. Like if you think a service is not going to change the next 6 months, you can put date of next review 6 months. But again, it's up to you how you want to do this kind of matrix. So you have the data review, that next review, but for me, that's important because if you want to track what's your next threat model, which service needs a threat model next, it's good to have all of this in place. The version, like, is this the first time you're creating this scope? You put the service in scope, the maturity. So we had initially the Pioneer threat modeling maturity level called Pioneers, which we actually just encourage devs to play the OWASP cornucopia game. And then we called the settler one, where we just actually have a meeting with security. And then tier is actually our criticality tier. So you can obviously have your own, you can call them high, medium, low, or you can just have 1 to 4. We created a criticality matrix based on what's external, what's internal, what are, what's business critical, what's not, so on. Then these are the repos that are affected. As I said, you can have multiple repos.
Petra, just a question. Where do you use this data? This is one of the data you store in JSON, right?
Yes. Yeah. So this is, I'm showing you how it will get created, basically.
Yeah,
this
cool.
Jupyter Notebook is essentially something that just assists you in creating it. It helps creating it. Ideally, I would be like a JavaScript developer who would create a nice UI on top of that. But yeah,
there's a cool project, right, for somebody to help in, right?
Yeah. If there's any JavaScript devs, it doesn't have to be JavaScript. I just said it JavaScript, but it doesn't have to be. Anyone who wants to create a UI on top of this, please reach out to me. We can do something together. So yeah, and then you have code review. Like, for example, if you're going to have someone doing a code review later at a later stage. So I put this field as well, because, sometimes after the threat model, you proceed to do a code review because you kind of then have an understanding of, what the application is, what it does, where are the flows, and then you know exactly where to look at in the code, which we have a, application security engineer who does that for us. And then security testing, like, have you done a penetration test? Have you done any SAST or any other tests? Is again very kind of open, up to you what you want to put there. Live, not live is the, application live or not live. And then new ports. This is more for kind of things that are very infrastructure based. Some applications always have the standard port, so it's not necessary. And then new endpoints. If you're opening a bunch of new endpoints, probably worth adding here so you can keep track. And as I said, once later, you can create dashboards on top of this. You connect to the GitHub API, and then you can create a lot of things with this. And this is a good way to track, like, even all your endpoints, for example. And then actors. Who are your actors? Like, is the user, you have the DevOps team or any other actors? What are their roles and privileges? And then you can write down some storage because it's important, to understand where are your databases, where's your data? And it's important to know, is this containing confidential data? Like, is there any, personal sensitive data in it? So this is all super important for you to track and understand your application much better. And then you have your trust, your trust boundaries. You have the internet with the service, or maybe, if you have super sensitive information in the database, the database shouldn't really trust anything else. So you put a trust boundary there. So it really kind of depends on your environment. And then
And
infrastructure.
one little
Yeah.
thing. What's really
Mhm.
cool about this is that you can then link this with tools like AWS or Lacework or other technology that or Wiz or some of the other guys who actually give you, Datadog, et cetera, who have data that
Exactly.
actually contains reality, right? And like, so you could even take a Kubernetes, manifest or an analysis of a real-time Kubernetes thing and say, hey, either you can generate some of this programmatic, or you could at least know what's the expectation, right? Of, hey, this thing is not supposed to be connected to the internet. This thing is not supposed to be talking to XYZ, but I can just see on the logs that it is, right? So that's a really great way to provide context for a lot of things.
Yeah, exactly. And that's kind of what Han is going to talk about, what we're doing as well with Enzo, in that kind of sense. So yeah, absolutely. This is kind of where the context comes in. Like, why are we actually doing this? What's the point of the whole thing? And then interactions, like which services are interacting with your service in scope. So, this service in scope interacts with different other services that are inside your environment, or they can be interacting with a third party. It's all important to note here. And then you can put some links to documentation. You can put some next steps. The next steps are usually kind of like, address security controls before production. You can just say address high security controls before production. You can say, oh, we want a code review, or we can say, are we going to have diagrams as code? We can say if we haven't listed all the endpoints yet, because they're not ready yet, we do it later at a later stage, so that whoever creates the version 2 knows kind of what to put in the second version. And sometimes we need to clarify some more things, so you can put in the next steps, like, okay, we clarify the roles, we clarify the privileges.
And if you use something like Jira or others, you can now create issues and tasks from it, right? So you can follow up.
Yes.
And you send,
Yes.
you can connect back and update it, right?
Exactly. And then this is your kind of main juicy part, right? Like, where you can put some risks. Like, if you identified some risks that could go to all the way up to enterprise risks, you can note them here. And then that could also feed into your risk management. Like, if you got some sort of risk management SaaS solution, a lot of them digest, if not JSON files, they can digest CSVs, and this is easily transferable into a CSV. So,
but by the way, one more thing, it is the kind of data. I'm not sure if you're doing it right now, but you could also store this data instead of JSON, where you have an intermediate step, which is to convert this to save it to JSON. Because I found that sometimes what you end up doing here is actually a really nice way to capture data, right?
Yeah.
So that code block can be saved as a Python file.
Yeah, it could be
You see what I
separate.
mean? Because it reads nicely. Sometimes I agree that sometimes the YAML can get a bit messy, right? So this is almost a very interesting middle ground between Python and JSON. And there's things that sometimes you might want a little bit of code, but it's a great way to capture information. So you can almost capture as a Python file that you run to create the JSON file. Then it's just a matter of deciding which is the master, because it will be harder to go from JSON to here, but it's easy to go from here to JSON.
Yeah, and that's basically what I'm kind of similar what I'm doing here. I'm just creating, Python, this is not a JSON yet. These are Python dictionaries, and with nested lists, and that's kind of what I'm doing, similar. So then you have like your threats, and in terms of threats, we like to, you put the threat, you can put the existing control. If there's already like a control that mitigates that risk, you can just put an existing control. You don't have to put a suggested control, but at least it shows that you've addressed it, that you kind of thought about it, that it's there.
Yeah.
And then you can put like suggested control, what else do you want to add to it? You can put your threat actor, and you can put your priority, like how critical you think this threat is, like based on these controls. If there's a lot of existing controls, you're probably not going to think that this threat is critical, right? It's going to be low because you've already kind of, if you have a good WAF that mitigates a lot of it, it can mean that you can put it as low. So these are your threats, and then you kind of, you put that, and then you have your facts, which is kind of, maybe you can rephrase this word facts into facts as of now, because obviously facts change all the time.
Yeah,
but these are some
facts are great. They're really first. One thing I was noticing is that you don't have a lot of IDs, so it'd be interesting to think about how you can add unique IDs when we scroll up, especially because a lot of those will be reusable to a lot of different things. So you kind of want to find a way to have unique IDs, for example, for your threads, for your stuff. They don't need to be very super complicated, but just by having a unique ID, maybe even on a title as a convention. Do you know what I mean? Because you want to be able to synchronize these across different applications, right? And at the moment, you force the text to be the key, where if you have an ID / the text, then you could always have a bit of logic just to use the initial ID as your key.
Yeah, it can help. I agree. I definitely agree that could help later. So yeah, and then what we do, we just form this JSON, right? Like these are this little thing I created down is just stripping the empties, I call it. We're basically, what we want to do is, if anyone left anything here empty, like for example, if things are not applicable, so instead of removing the whole thing, I just made it easy for anyone just to leave something empty, and then you run this little loop, and basically what happens is you get the JSON, and then once you have, this will get you this nicely done JSON. What I couldn't get myself, I couldn't do is create a way to get this JSON as a variable inside this Plan2ML magic, but maybe someone who's a better coder than me can figure that out and help. But what I do is this manual step, I just copy paste basically this nice little pretty JSON then inside here, inside the UML. And then what happens is you run it and you get a graph.
Woo.
So, the graph just helps to visualize it a little bit. If you want to use it as like a discussion point with someone, how everything ties into everything else. And, at some point you can even merge a lot of these JSONs into one monster threat model JSON as well. So, having a graph can be quite nifty, because then you can start showing the connections between each other. So, yeah, that's kind of it from me in terms of, how to create it. And essentially the next step is what, everyone asked me, like on my previous session, is, okay, so you got you got your framework. What do you do then? Well, as I said, if you put it in GitHub, it's quite cool because you can also do peer reviews, right? What we do is we get the devs to create it, and then we as security do a peer review. And then you can see like what teams are doing which threat models, how many are there per team. You can use the GitHub API and connect it to a lot of other things to actually get that information then from GitHub. And then you can push it to other solutions like, a SIM, Enzo, with Han is going to say in a minute, Datadog. Yeah, like all of these things you can then later do with this data, because then you got a data that's machine digestible, and then you can use that to fortify your security posture. Cool. I'm going to hand over to Han now.
Thanks, Petra.
And I'm going to
share. Yeah, I'm going to share my screen.
Petra, you use Plan2ML in that case, right?
Yeah, for creating a graph, yes.
Yeah. Where are you running the Plan2ML? Directly on the notebook?
I'm running the Plan2ML. Yeah, so it's run inside the notebook. I'm not sending it to a distant server, because you have two options. You can either send it to a Plan2ML server, but I thought like it's not really cool to send threat models to a distant server.
So you run the Java directly there, right?
Yeah, exactly. It's run locally, and that's why you need this environment or YAML file for all of these dependencies.
Yeah.
But yeah, you're basically running it inside locally.
Yeah, I've been doing that quite a bit. We probably need to share some notes on. I found some scalability issues, but there's a bunch of options that you can use in Plan2ML to allow to make massive graphs, right? Which is actually pretty cool.
Yeah, exactly.
Let's think up on that thing. There's a way to pass the variables around. I can show you how to do. Cool. All right, let's look next bit.
All right. So thanks a lot, Petra. Very interesting.
Wait, Timo has the hand up. Sorry.
Yeah.
Quickly, Timo.
So just to summarize for me, it's not about finding threads. It's more for documenting them when you found threats afterwards?
Yeah, so it's basically you find the threats, but what do you do with that data now? And it's also for the evolution of that data, because as I said, these threats don't stay the same because the software doesn't stay the same. The environment changes, the context changes. So this is more of like, where does this data that you found after the threats comes into the bigger picture inside your organization?
Yeah, and I think that, and it's another thing that we are going to discuss now, is that when you build a process that has this quality of being of recording itself and accounting for all the changes in it, it is much easier to build also a framework of, okay, so what are the questions we're going to ask? Petra already has a script for to seed the question that she wants to ask as part of a threat model. And as they do more and more of that, they will have more in that seed and the baseline for doing all of it, not only the threat modeling, but also the attribution of the security scope context that the file is representing will become richer over time. And with advanced in the project, they can also pull in more data automatically and populate it.
Yeah.
So I think that this is a great point in the discussion to start discussing how we help with Enzo on this campaign of Petra. So Enzo is essentially an ASPM platform. And before I'm explaining what does it mean for us, I want to talk about why we started it. All to give context into how and why we are helping German Talent and Petra to build with this approach. How come we have such a great fit for that? So the reason we started Enzo is to account for a few main gaps that we recognize as a team practicing application security. One huge problem is lack of visibility, incomplete visibility, visibility with not enough abilities to ask questions of the visible data. Data is scattered. Main data sources are the engineering data sources, most notably the code. Like Petra explained, the code is a very good common ground for application security teams and software developers. It's maybe one of the places where we have the most visibility. Most teams have more visibility than in other places. So if you talk about maybe production plane or deployments, when we go more to the right, AppSec teams get less and less visibility usually. And the code is a very good common ground, and it's a huge place that we can collaborate on adding additional clues regarding what we see. But at large, if we look at the toolchain that we have today to get good visibility, they're broken down. It's hard to say what's what, and it's hard to lead a process of understanding what you have so you can prioritize your actions on top of it. On the other end of the scene, even if you build a lot of tools or scripts or methods to acquire the information once you need it, without the proper tools for managing this process, it is very, very hard to scale. So think about, if we compare it to developers, we operate in a model that is equivalent to developers operating without Git, for example. They merge their code with automated code management system. They have a lot of assist on collaboration, but if we compare it to the kind of tools that we have sometimes to govern the process, to do the things that we do, we think about spreadsheets, or if we are a little bit more advanced, properly managed Jira tickets, but it's not as effective as what developers have in this area. And the result is that it's very, very difficult to get to a place where you actually take control and manage your application security program. And this is why we started Enzo. And our approach to the solution was apply what we call the application security posture management. And it's basically application security delivery model that says that what you need to do is you need to inventory all assets. Very simplified model. You say you need to inventory all application assets so you know what application assets you have. What's the definition exactly of an application asset? Every team have a slightly different definition, but again, nonetheless, what you think is an application asset, you need to inventory it. And then you need to account for all the controls you have over that asset in the inventory, across the entire inventory, so you can build a metrics of these are the assets and these are the controls. And then you operate on that metrics by automating tasks that will let you get more green dots on the metrics, but also prioritizing the red dots that are related to the assets that are more valuable to you. And with this systematic approach, you can accomplish application security maturity over time, and you can build up a program that is suitable for what you need today. How do we deliver it with Enzo, our platform built for this? So we have set some design principles in our platform to do this ASPM. And our design principle is that we are inventorying from any data source. We don't need to use strictly defined data source to create an inventory from. Of course, our platform inventory out of the box assets that you will find in a GitHub SCM, for example, but you can extend it and in many different ways, like we did with the security JSONs. We can again also create control information from any data source. Again, no restriction about the data source, and again, synthesize alert or create alerts again from any data source. When the normal operation of the platform is that we have many standard data sources, engineering data sources, or application security data sources that are naturally existing in an environment, and and we pull from these, and we create the standard things and extend it per need for our enterprise customers. Then what do we accomplish after we did this, and why is this so effective for the teams that are using this? Is because it puts AppSec in the center of its story. The story of application security is becoming the focus of their attention. They build their own device strategy to tackle the application security problem, and it's usually what we advise, and that's what we find that is most effective, that they deliver mainly two things. One stream of delivery is to developers, and this is about making more interesting or more easy. First of all, more easy, but then also more interesting for developers to collaborate on security activities. Make it easy for them mainly, so that when their input is needed, the easiest way for them to give it. And on the other side, with the executives, to be able to reflect the progress and the challenges and the problems to executives, so they will give the team the mandate and the resources that they need in order to accelerate their activity and give developers more services and more options to accomplish easy security eventually. All of it is, of course, with this asset prioritization, asset first approach to application security, which means that you push, that you work based on the real urgency of the problems when you consider your actual asset criticality. So you are not prioritizing activities on assets that are not important, because you have a lot of things that you need to do. Yes. I think there is a question. Right, I thought someone raised their hand. Okay, I'll continue. So when it takes us back to, with this approach that for ASPM and our delivery model and the way that we are delivering it with Enzo, adapting the effort of Petra, had a lot of using Enzo together with it as a lot of advantages. The main things are that eventually when you adapt the kind of content that you find inside the security JSON, you can create many different things from it. You can learn about the asset context, and then you can assign asset criticality from the data in the facts, in all the parameters that Petra showed. You can transform the existing threats and findings inside already to tasks and defects that are managed in a unified way, the same way that your sneak tasks are being managed. Consolidate all of it, and then once you've done all of this, it gives you a unified measurement option on top of it, and also the full tool chains of automation of Enzo that you can automate on top of the output of security JSON. You can automate the same way you would automate out based on the output of sneak. You can automate based on security JSON, and also automate the actual governance of adapting security JSON. So I think the best way to explain this will be to show it. So I'll jump right into an Enzo platform, a demo tenant with scrambled data that was adapted to include an anonymized security JSON files. This demo environment is fed with data coming from many different sources. Enzo can read from virtually any data source. We have a lot of implementation already for a lot of connectors. But in this specific case, to showcase the JSON, the security JSON file created from the toolchain that Petra presented, we have adapted the recipe for that implementation, and also created dummy security files along the inventory in here. From the data that we collect from all these, we build the inventory. We can visualize the inventory in a few different ways. This one is focused on the organization. This one is focused on the repository, the code base. And in here, in other implementations, we of course have more views based on what everybody needs. But in this view, we can already see that there is this Enzo control that is governing the process and pulling extra data from the security JSON file. We can see that, for example, in this context, we have one critical issue coming from Enzo security, and this is from the digestion of the security JSON file. This lives side by side with the rest of your controls. So this context has information from sneak, has information from checkmarks, but it also gets fed with the security context from the effort of the managing the threat model in code. If you go to defect, we can see that in this case, the defect is not even about the threats inside. It's about the fact that this is a critical asset. This is a class A asset, but it does not have yet a security JSON file. And the next step to do will be to attach a Jira ticket to create this file automatically. And this is created automatically by Enzo that looks at the class A of the asset. The class is actually inheriting from the tier parameter that Petra shows, but you can also override it directly from the UI. And when Enzo sees a class A asset without a security JSON, the asset will automatically be attached with a defect saying that you need to adapt security JSON. In this asset, we do have a security JSON. We have no problems. Let's see how it looks like. We go to the attributes of the asset. We can see all the information collected by the Enzo platform. It's information from many different places, and also the security JSON itself with all the data inside. It's been included as raw data, but it's also used in the different Enzo engines to calculate defects, like for example in this one. Let's see how many issues we have here. We have a lot of issues from the engine. Let's see what we find inside. So if we go to defects, we have a combination of asset not classified for criticality tier and threat model findings coming directly from the security JSON file. With this, all of them have the features of closing them, changing severities, adding tickets, and it will be correlated back with the updated from the security JSON file. And of course, the security JSON file is a source of truth, and Enzo can learn from it and can accommodate overrides on what's inside. And as the final result is a clear breakdown of assets and association of different controls, which controls run on what assets, plus the aggregation of all this data from all the controls. All of it together is becoming uniformly measurable at the Enzo platform data core, which let us bring some different kind of dashboards around it. But if we look at the settlers dashboard, we can see immediately, easily, the next steps in the threat coded modeling campaign. And we can see that the next step is to adapt it where it's most critical, and then move on to solve the problems on the prioritized assets, and then move on to less prioritized assets. It's automatically created by Enzo. Every time that there is a change, this list will change. We can also see the breakdown of different defects. These are about the missing criticality tier. There are a few high findings coming from the threat model questions themselves, and the criticals are not having a missing security JSON on the asset. We can also visualize how much of this activity has covered our entire inventory. If you look at repositories of class A, B, C, and D, we can see that class A is the policy request demands that there will be 100% coverage, but we are only at 70. And for the rest of the classes, at the moment, we don't have a policy because we first want to accomplish this. So this will drive the main future backlog for the process. Again, with this prioritization that can be based on problems that we have, but also a problem can be that we haven't adapted the security control properly yet. And all of it is also available in automation. For example, the must-have security JSON automation is built like this. So if you don't have, if the asset type is repository and the class is A and it has a security JSON, I want to automatically create a task. I can also change it to send emails, to update in different ways over Slack, and this is how we help governing and also transforming some of the things in there to actionable items that are a little bit more integrated into, have the ability to integrate into into the workflow in many different ways. And this we get more and more options to approach developers, engage with them in their own language, on their own data plane, and govern the process to see that we are making progress, more coverage, and eventually improving on application security. And this is a huge and wonderful instrument. And it is very similar to our approach in its final consequence. And I think Petra talked about this quite a lot in her part. And she said that the main advantage is of keeping this kind of data in a format that is available for automation, for integration, is a computer readable, machine readable format, lets us combine it with feedback that we get from automated tools. This is the same as what we do already with our burp extension, for example. So we have, it doesn't show because we don't have the view in here, but we have data coming from a burp extension that is tapped into the Enzo platform, tracking the activity of pen testers. It's another place where human data is being integrated into the ASPM plane, so we can measure all of it. And the security JSON is a huge step forward for teams that adopt it, because they can clearly attribute assets. They can let their developers clearly attribute assets, and they can manage it on this platform that is a common ground between developers and security folks. And the result is that it is measurable the same way the rest of the activity is measurable. And this is a huge thing when you come back to the developer leaders group and tell, okay, the commerce team has 5 different problems. Some of them is about not managing the security JSON properly, or I clicked on not the one that is talking about this specifically, but it's easy to go to developers managers, but it's also easy to show executives what is our status in terms of our campaigns and how much we are benefiting from it over time as we run it.
Sorry, we had a question by Timo, which is good. Like, he's asking if Enzo is open source. So Enzo is a commercial product, but Enzo is just an example how you can use this data. So for example, you can also put this data into Datadog, which is again a commercial product. But something that, for example, our backend teams have done is they created also some dashboards where they have like a check, if any service doesn't have a security JSON, it's a fail. And that's also a way that they're trying to we're introducing some standards. So in short, Enzo is just one of the ways that you can use, and to kind of utilize this data after you've done it. And why Enzo is useful for us is because we also have some, for example, vulnerabilities in there, like SNCC findings, you can burp suite findings, you can all correlate that to the security JSON. So you can actually say that some of the findings are the same, because at the end of the day, even you can probably put pen testing findings there as well. So at the end of the day, a threat model is a kind of penetration test on paper. And a lot of things that you actually find on a threat model, maybe it's something that your tools are already highlighting. So it's good that once you get an association with it. And this is kind of, for us, it's quite useful because, besides having a whole asset inventory, we also have an inventory of our threat models and the criticalities of these assets. I hope that helps. I kind of expanded on the question. Cool. So Han if you're kind of reached the end of your presentation. I'll
Yeah,
just-
I'm done. Any
Mhm.
other questions I'd love to answer? Oh, yeah.
So Avi, curious why you decided to build this from scratch versus using one of the other. Okay, so good question. The reason is because they're for different things. So PyTM is it's a Python framework that you can use to actually generate those threads. What we're doing is we are having our old style, classical thread models, but we're doing the outputs as code. So it's a bit of a different, the PyTM framework is the thing that, will get you the automated threads. But, having a security.json is, threat modeling as code as per output. So it's more of a, tool that you can use not just for the threat modeling itself, but more like to track the threat modeling, to track the controls, to track the maturity of your security within your organization. I hope that makes sense. And, I'm happy to chat about this with anyone, our experiences, how we introduced it. I have loads of ideas, like how can this be put into dashboards, even like, thinking about some, generation of threats later down the line. Like if you have a data set of all your kind of threat models, then later on you can use that to, pre-generate threats, because then, the system will know, for example, that if applications that are internal and communicate with certain other applications, we already have a preset of some certain threats that you have to consider and take, so there's a lot of possibilities on this, and I'd love for people to, contribute, create an issue in GitHub, create a pull request, give me a shout. I'm sorry if sometimes I'm unresponsive. There's a lot going on in my life right now, but but I will do my best to chat with you guys, and whoever wants to get involved, I'd love to hear your thoughts on this. Cool.
I think that's everything then.
Yeah.
Brilliant. Thanks everybody for coming, and thank you for your great presentation.
Thank you very much. Thank you, everybody.
Oh, hang on, have we got another question? Hang on, wait.
Are we still okay? I was going to end it up. One more question.
Oh yeah. Okay, Timo. Yeah.
But you guys stop. Oh, we're still recording. Cool. All right, I'll go for it.
Timo just made an opinion, and yeah, point taken.
Yeah.
Yeah. Yeah. No, I agree, Tim. That was a good point. All right, good stuff. Well, Petra, Chen, thanks for this. Really great topic, and I see you at the other summit sessions.
Thanks for having me.
Cheers. Thank you. Bye.